dreamt up of fairy tales and science fiction for centuries that one day we'd be able to hold back the ageing process and remain forever young. But this year's Nobel Prize for Medicine has provoked a rethink.
Two scientists have been awarded for their work in reprogramming mature specialised cells into becoming immature stem cells, capable of developing into all tissues of the body. For our resident science guru, Dr. Carl, this has brought us closer than ever to achieving immortality within a lifetime.
Reverse mature cells and turn them back into stem cells. Isn't that amazing? And I used to think that was a one-way trip. So what I'll try and do is put it in the context of how I see the big picture, which is the 5 stages of genetic engineering. First stage we did back in 1985. Before then, if you wanted insulin as a diabetic, you'd get pig or cow or dog insulin or dinosaur or some endangered animal and inject it into yourself. It wasn't quite human insulin, there were side effects, and so what they did was they modified a fungus to give us human insulin. And that was the first stage of genetic engineering. Second stage, on a scaffolding, they could grow some sort of approximation to a human organ, like a larynx or a human bladder, and then via an operation transplant it into the person. That was the second stage of genetic engineering, which had nothing to do with stem cells. Third stage, now this is where we're going to go into the stem cells. The third stage would be where they repair an organ in your body. So you might have type 1 diabetes where your pancreas can't make insulin, or your thyroid gland might not make thyroxine. And so instead of injecting it into you, what they do is they mutate the organ that you have in your body, while it's in your body, to make insulin or thyroid hormone. The fourth stage, we're going to come back to the third stage, the fourth stage is basically immortality. We do this over the whole body. So you, Miriam, you could be in the first generation to live forever, whereas I, being a bit older, could be in the last generation to die. Oh, well, you can't win them all. Bummer. But the point is, by living forever, I mean 500 to 5,000 years with a healthy 18 to 25-year-old body. And then the fifth stage of genetic engineering, who needs a human body? Freeman Dyson said that the proper shape for a human being is a cloud of iron vapour weighing 50 kilograms, the diameter of a planet, floating through space. And we could modify ourselves to live on Mars without a spacesuit, in the oceans. Anyway, so they're the 5 stages of genetic engineering. Okay, so now we come back to the stem cell thing. Any questions at this stage?
Well, it's just in terms of how have we got to the stage where we're actually able to manipulate the cell itself to become something that it wasn't. So
it was a 2-part process, and these are the 2 guys, Gurdon and Yamanaka, that won the Nobel Prize. Gurdon did his work back in the 1960s, and basically he got a fertilised cell, an egg cell, of a frog, and he ripped out the nucleus, and then went to another frog, a tadpole, and got a gut cell, pulled the nucleus out of that, and inserted it into this empty egg cell. So now, this gut cell, well, it had changed from something into being a gut cell. It was always going to be a gut cell, and blow me down, it went backwards. It went back to something like an embryonic stem cell, something like a pluripotent stem cell. What Dr. Yamanaka did was he did the same sort of process-ish, in other words, get a mature cell from somewhere in the body, and in this case he got mouse skin cells, and by inserting various genes he made them go backwards to this beloved embryonic stem cell. And this is the sort of stem cell that we can use for repairing different diseases, and which is fraught with all sorts of legal, ethical problems if you try to get one from an embryo. But if you just simply go and scrape the skin and then do stuff to it, then you're using your own cell off your own skin, and you can then take it back to an early stage and then run it forward to repair, for example, the thyroid gland that doesn't make thyroid hormone, the pancreas that doesn't make pancreatic hormone. So in my case, the only reason I'm a useful member of society is because of these bits of transparent rock. Engineers invented this transparent rock, we call them glasses. I'd really like to be able to drink a glass of eyeballo, and then something magically would happen to my eyeballs, and then they would grow back to the size they should be. These stem cells, they make us and they repair us. And what the Nobel Prize winners have done is found how to get an adult cell that's gone away from the stem cell and bring it back. And that's why they won the Nobel Prize for this remarkable achievement.
So how far off are we from achieving what you've stipulated there as essentially immortality? Is that something that's imminent?
It took from 1903, Wright brothers, to 1969 to get to the moon. Somewhere less than 66 years. I'm thinking 30 to 40 years. The first treatments will come online in 20 years. We're doing that sort of stuff with cell culture now. But to do one thing on a laboratory bench is different from a human being. So suddenly you can have really young skin and then young muscles and young hearts. And we work through all of the different organ systems. And at some stage we'll be able to make the body bring itself back to what you had when you're 18 to 25 years old. And then you wear that body for effectively forever, 500 to 5,000 years. How long? 20 to 50, 70 years. Bummer, I'm going to miss it. Bummer, man.